Okay. Let's start. Hello, everyone. I'm glad to be here. And before we start, let me introduce myself. I'm Mohammed. I'm a Microsoft MVP in Microsoft 365 development, and I'm an experienced .NET and Azure solution developer. I'm working as a tech lead at Atea Global Services. I've been focusing on leveraging the Microsoft ecosystem, specifically Azure and Microsoft 365, to design and deliver business solutions on top of Microsoft 365. Before also we start, let me tell you a little more about Global AI Riga community. The Global AI Riga is part of Global AI community. It's a Microsoft community. And we are excited today to kick off our community and our first online event, Learn MCP. Our today's event title is Season of AI MCP. We will be organizing other events soon, so please stay tuned and join our meetup group. Of course, special thanks to the Global AI community for helping and supporting us to have our chapter here in Riga. I will be leading the Global AI Riga chapter, so please, if you would like to contribute or help with organizing upcoming events, write to me in Teams or LinkedIn after our event. Feel free to reach out or connect with me through the social links that I will be sharing shortly with you. One last thing before we start, I would kindly ask you to write in the chat one thing you learn while I'm presenting. Every time you feel you learn something new, write in the chat. And let's make our session super interactive. I will be talking and I will be also taking your questions during my presentation. The agenda for today is going to be about what is MCP, how does it work, and how do you use it. In-depth overview of MCP features. And the important part and the fun part, real-world scenario about the Microsoft Learn MCP server. Building an MCP server. And these are the tutorials that will help you to learn and implement your first MCP. It is in different flavors, so if you like to code with C# or Java or Python or JavaScript, you can start from any of these languages. What is MCP? Imagine you only know English. To get info from a person who knows only French, you must learn French, right? And the same, if you want to get info from a person who speaks German, then you must learn German, and so on. In this setup that you see in the slide, learning 5 languages will be a nightmare for you, right? But what if you add a translator that understands all these languages? If we have a translator, like the setup that you see in the slide, it will make everything look different. So this is simple, isn't it? The translator is like an MCP here, and it lets you talk to other people or other capabilities through a single interface. Let's switch and talk about agents and capabilities. So the MCP in this case lets agents to talk to other tools or capabilities through a single interface. All right, to formalize, while LLMs possess impressive knowledge and reasoning skills, which allow them to perform many complex tasks, their knowledge is limited to their initial training data. So if they need to access real-time information, they must use external tools and resources on their own. So Model Context Protocol is a standardized interface and framework that allows AI models to seamlessly interact with external tools, resources, and environments. MCP acts as a universal connector for AI systems to capabilities, tools, etc. Similar to how USB-C standardizes the connections between electronic devices. All right. While I'm presenting, I will rely on some screenshots from GitHub Copilot showing you some demos from how GitHub Copilot acts when we deal with GitHub Copilot in VS Code. In this slide, what you see is GitHub Copilot in VS Code. And now in VS Code and Visual Studio, we have agent mode. And this agent mode makes Copilot even more powerful by turning it into real autonomous AI. And now when you ask agent mode for assistant with something, it can plan, execute, create on multi-step task. It can also execute terminal commands, edit code, and run tests, and even debug. We, or maybe some of us know that, but that alone is pretty powerful, but still missing a key piece, which is that we talked about the real-time context. Then the questions here are, how can we make Copilot aware of our external databases? Or how can we show it the issues coming into our GitHub Copilot repo? And how can we connect it with the tools and resources that are not part of our IDE? That's where MCP comes in. So how the MCP arises? This is the timeline that shows how the MCP arises, because there was no MCP, but by AI developers, the MCP arises. But how? The need for MCP arises in this way. Developers have been working to come up with solutions to integrate different external tools and capabilities, but every new integration required its own custom implementation, which led to an explosion of custom extensions. And you will see in this timeline, this how the integration look like. There is, as you see, explosion, custom extensions, and plugins. This increased the maintenance and security and performance risks. And it was difficult to scale in this way. For example, if you are developing an app and you want to connect to different data sources or services, you would need to install several extensions and open several web pages or build a custom solution. But with MCP, life becomes much easier. So if your company or if you are developing a project or if you are a student or if you are working in a project in your university, so a bunch of different data sources that are managed by different teams, they may all be implementing external data integrations differently, which can be confusing and be redundant. And that's where the MCP comes. MCP servers provide a standard way or protocol to connect LLMs with data, tools, and resources. The MCP website describes MCP as a universal adapter for AI applications. And in the same way that a universal adapter lets you connect your physical devices to accessories, and MCP lets you connect AI applications to other data and tools without needing to build a custom connections to each data source. The important thing to remember is that model context protocol is adapting and evolving as AI changes. It was created by Anthropic and it has been adopted and adopted like a standard throughout the AI community. Why was MCP created? We explained that quickly in the previous slides, but let's make it more clear. With MCP, adding a new tool or integrating a new model was a headache. And if you have 3 AI models or AI applications like what we have in the slide, and 3 external tools, you might end up writing 9 different integrations between those models and those tools. So developers of AI apps were essentially reinventing the wheel each time a tool should be added. So the developer of AI apps essentially reinventing the wheel each time, and the tool provider had to, by tools, these tools, database, file system, and calculator. The tool providers had to support multiple incompatible APIs to reach different AI platforms. Let's understand this in details. The problem. Before MCP, the landscape of connecting AI to external data and actions looked like patchwork of one-off solutions. Either you hard code logic for each tool, like these arrows, you hard code logic for each tool like that, managed prompt chains that were not cropped, or you use vendor-specific plugin framework. And this leads to infamous M multiply N integration problem, meaning that if we have M of models and N of tools, then we have to multiply M with N to understand how many integration we should have here in order to integrate the models and tools. Essentially, if you have M different AI applications and N different tools or data sources, you could end up with M multiply N custom integrations. And the diagram in the slide illustrates this complexity. Each AI or each model might require unique code to connect with external services or databases or file systems or calculator. This leads to spaghetti-like interconnections like what you see. So what is the solution here? MCP tackles this by introducing a standard interface in the middle, as you see on the right. So instead of M multiply N direct integrations, we get M plus N implementations. Each of M AI application implements the MCP client on one side or once, and each of N tool implements the MCP server once. So the model or AI application implements MCP once, and the tool or one tool implements the MCP server also once. Now, everyone speaks the same language. So to speak a new language in this structure, a new pairing doesn't require custom code since they already understand each other via MCP. Just adding a new tool and connect it to the MCP. The diagram in the slide illustrates this shift. On the left, this is like pre-MCP. Every model had to wire into every tool like that. But on the right, with MCP, each model and tool connects to MCP layer. This simplifying connections, and you can also relate that. We can relate that to the translator example that we discussed earlier. So MCP here like a translator between the AI and tools. All right. Now we know why we have MCP, what is the problem, and the solution. But we also should know that there are parts of MCP. In order to have MCP structure, then there are three parts. There are three main parts to know about when talking about MCP. At its heart, MCP follows the client-server architecture, much like the web or network protocol. However, the terminology is tailored to the AI context in this case. So there are three main rules to understand the host. This is the first part, and the client and the server. Let's take these parts one by one to make it more clear. The host. The host is the user-facing AI application, the environment where AI model lives and interacts with the user. This could be a chat application like OpenAI's ChatGPT interface or Anthropic's Cloud Desktop, or an AI-enhanced IDE like maybe Cursor or any custom app that embeds an AI assistant like maybe VS Code or Copilot Studio or any IDE. Host is the one that initiates the connections to the available MCP servers. We will see that in few minutes, and we will see ready-made MCP servers that we can initiate from or within the VS Code host. So the host is the one that initiates the connections to the available MCP servers when the system needs them, and it captures the user's input and history, and it displays the model's replies. So I believe that you got the point here if you are using GitHub Copilot or any ChatGPT IDE. So we know about the hosts. But what is the client? The MCP client is the component within the host that handles the low-level communication with an MCP server. Think of the client as like adapter or messenger, while the host decides what to do. The client knows how to speak to the MCP to actually carry out those instructions that you send with in the host with the server. Then what is the server in this case? What is the MCP server in this case? The MCP server is the external program or service that actually provides the capabilities like tools, data, etc. to the application. An MCP server can be thought of a wrapper around some functionality, which exposes a set of actions or resources in a standardized way so that any MCP client can invoke them. Servers can run, and this is also an important point here, servers or MCP servers can run locally on the same machine if you are developing something locally, for example, or remotely on some cloud services, since MCP is designed to support both scenarios. But the key here is that the server or MCP server advertises what it can do in a standardized format. So the client can query and understand available requests coming from the client, then return the results. Again, the key point here is that the server always advertises what it can do in a standard format. So the client can query and understand available tools and will execute the requests coming from the client and then return the results. These are some links if you would like to start build a simple MCP server in different languages. So you can choose the language that you prefer to start with. I'm going to share with you some links as we have done the first part. Hopefully you will learn something new. Let's move forward. Let's deep dive a bit. There are something called tools, something called prompts and resources. Tools, prompts, and resources are the three core capabilities of the MCP framework. These three capabilities are essentially the features or functions that the server makes available. Let's start with the tools. Tools are executable actions or functions that AI or host can invoke, often with side effects or external API calls. But tools are executable actions or functions that AI, host, or client can invoke, but often with side effects or external API calls. So let's repeat again, because I think I mixed the tools with resources. Tools are the executable actions or functions that AI, either host or client, can invoke, but remember, often with side effects or external API calls. But what about resources? Resources always read only. Think of text file as a database for you, and you would like to get some data from this text file. So resources are read-only data sources that AI, either the host or the client, can query for information. And in this case, no side effects, meaning that no retrieval, just retrieval, no updates. In case of resources, you just retrieve something from files or database or get responses. But the prompts, what are the prompts? The prompts are the predefined prompts or templates or workflows that the server can supply. So we are good with the tools, resources, and prompts. Let's deep dive a bit with the tools, resources, and prompts, because these three parts are important to understand. The tools are what they sound like, as I mentioned before, functions that do something on behalf of the AI model. These tools are typically operations that can have effects or require computations beyond the AI own capabilities. Importantly, tools are usually triggered by AI models' choice. So it's not triggered like without any choice. It is triggered by the AI model's choice, which means the LLM via the host decides to call a tool when it determines it needs the specific functionality. So the AI model will not send email or update to-dos or run tests or file issue bug without a choice. You have to give this choice and then it will do it. You have a lot of control over the tools availability. You can configure them per project or per system-wide. You can also select directly which ones you want to use when to make chat requests, and so on. You can use them in the prompt directly, and you can even define tool set. And I will show you how in GitHub Copilot, how to choose your tools. So, for example, you may have a research set or a coding set of tools, so you can easily jump between them based on what you are trying to accomplish. And these screenshots are from GitHub Copilot. Then the resources. The resources provide read-only data to the AI model, as we mentioned. These are like databases or knowledge bases that the AI can query to get information, but not modify. Unlike tools, resources typically do not involve heavy computations or side effects, so just retrieval. Since they are often just information lookup, as I mentioned, files, documents, databases, images, and so on. Another key difference here is that resources are usually accessed under the host's control. So in practice, this might mean that the host knows when to fetch a certain context for the model. What is nice here, you can easily give the agent data directly. And I believe all of you have tried that. So it doesn't have to go fetch the data, but you can provide data back and attach it. Then the prompts. Prompts in MCP context are special concept. They are predefined prompts, templates, or conversation flows that can be injected. And also, I believe that all of you have tried that to guide the AI behavior. Essentially, a prompt capability provide a canned set of instructions to guide the AI how to achieve your tasks. Or an example dialogue that can help steer the model. So with these prompts, you can steer the model for certain tasks. But why have prompts as capability? Think of recurring patterns. For example, a prompt that sets up system rule as you are a code reviewer, or you imagine you are a code reviewer and the user's code is inserted for analysis. Rather than hard coding that in the host application, the MCP server can supply it. So prompts can also represent multi-turn workflows. These are like various prompts for different use cases. Prompts can dynamically pull in real-time data such as GitHub Copilot, pull request, comments, and so on. I would really appreciate if you can add something that you have learned today in our demo while I am presenting, or if you have questions, feel free to write it in the chat so we can take it while we are presenting. Another important thing here to know and understand is this architecture. In this architecture, I will go through three different three parts, and it will make things also more clear for you. So local communication with local data. I'm going to start with the first architecture. So we have three architectures. I am going to start with the upper one, this one. Local communications with local data. So you can have your MCP local that access your local data. Local communication with local data. In this scenario, the MCP client talk directly to the MCP server running on your machine using MCP protocol. And that server then connects to local data. For example, files or databases or other resources stored on your computer. When to use this scenario? This setup is useful for local development or anytime you want fast access to data that stays private on your local machine. All right, let's take the second architecture or second scenario. Local server. Yeah, local server as a bridge to remote services. How does it work? Here, the MCP client here connects to MCP server running local, but instead of working with local data, the server bridges to a remote service using APIs. So in this case, it is calling remote service on the internet by calling its APIs. When to use this scenario? This model is common when a local tool needs to fetch or update information from a remote service, but benefits from having a local server in between. For example, to handle caching or security checks or data processing. Let's take the third scenario, remote communication over the internet. In this setup, the MCP client connects to MCP server that lives entirely on the internet. So the remote MCP server here is living remotely. So in this case, the MCP server is not living in your machine. That remote server then communicates with other external services via web APIs. When to use this scenario or this setup? This approach is best when the resource or computation you need can't happen locally, like using cloud-based compute, SaaS platform, or third-party integrations that only exist online. We have two questions. We can maybe take these two questions before we move forward. Yeah. How would you compare GitHub Copilot with Cloud Code? What are the top MCP server you use on daily basis? Well, we are not comparing GitHub Copilot with Clouda. Well, I'm using GitHub Copilot as I'm used to use it in my daily work. I'm not using Clouda Code, but I know that it's great and I'm planning to use it, but still don't have time to try it, but I will try it, of course. One of the top MCP servers that I'm using on daily basis is the Microsoft MCP server, Microsoft Learn MCP server. When does it make sense to build a custom MCP? This is a great question. When should an MCP gateway be used? And how should a custom MCP be designed? Well, let's take it one by one. I like the first part of your question. And the first part is we were trying to explain where to use custom MCP server. One example that might explain this part for you is imagine that you have local data and you are building a project, AI project, but your AI models doesn't know about your local AI, your local data. And in order to make the AI model knows about your local data, you should build, in this case, MCP server in order to do the connection between the AI model and your local data. This is a very simple example of when to use custom MCP server. There are ready-made MCP servers, and it is great to use these ready-made MCP servers, but it is ready-made for some purposes, like this one, Microsoft Learn, or maybe some GitHub MCP servers, but the custom ones, you will need them in order to connect the AI model to resources or tools or data that are maybe private or in your company or in your project, stuff like that. How should a custom MCP be designed? This question will be answered by following the links that I shared with you. In the Learn MCP links, well, not learn, but let me share these links. And in these links, there is a GitHub repo explaining how to start your first MCP server. And by going through the GitHub Copilot repo, you will understand how to design your first MCP server. Let me share with you these links. One moment. I know that this is a very interesting topic, and I would like to mention that it's not only about this session. We will, of course, after our session, plan for other events personally, so we can meet together and we can discuss different projects and different scenarios, different setup in other meetings when we can meet personally. These are the links. Well, let me share it in a different way. Just one moment. So you can try these links. It will walk you through the how to build your MCP server in different languages. Let's move forward. Let's take the Microsoft Learn MCP server as a real world scenario. And I'm going to start with the theory part, explaining this Microsoft Learn MCP server, what we can achieve using one example of a prompt. And then I will try to do the same in VS Code, and let's see what this Microsoft Learn MCP and GitHub Copilot will give us. So let's start with what is this Microsoft Learn MCP server? Microsoft Learn MCP server is a remote MCP server that allows AI agents to tab directly into the official Microsoft product knowledge base. Again, to the previous question, why Microsoft built this Microsoft Learn MCP server? Because there is a huge knowledge base for Microsoft documentation, and Microsoft thought, okay, why not building an MCP server that people can use and connect AI models with this MCP server in order to get information about many stuff for developers. And we will see in a couple of minutes how to do that. So Learn MCP server is a remote MCP server that allows AI agents to tab directly into the official Microsoft knowledge base. And not only this can be done inside your development environment or workflow. So while you are developing in using VS Code, for example, you can ask questions with the help of the Microsoft Learn MCP server. You will get an answer to your question. Not only, but also you can ask the AI model to apply the changes that was suggested by the MCP server. It is a simple to use, and it doesn't require custom connectors or installing extra components. It is ready-made something, so you can start just using it, and we will show how to use it. So the service using lightweight streamable HTTP, so it works with almost any MCP compatible tool. It provides tools to AI agents so they can service the right information. And the MCP server here does three main things. First, the focused excerpts, meaning the server can search Microsoft content and return up to 10 chunks of high quality information, each with a title, an URL, and self-contained passage. Second, the full technical documentation. When broader context is needed, the Learn MCP server can fetch and complete pages and giving agents richer and more contextual information. The third is code samples. So not only info or instructions, but also code samples. The server returns relevant language-specific code. So if you, in your prompt, specify that you want to build something using C#, then it might suggest you some code samples using C# or any other language, because it understands the context. So it is also, as we mentioned, aware of the language-specific code snippets from Microsoft Learn, and it is helping agents service accurate code for scenarios like deployments, scripting, or configurations. Yeah, let's here look at specific example of using Microsoft Learn MCP server. Developers can use the Learn MCP server within VS Code or Visual Studio to retrieve validated and cited deployment patterns such as secure deployment of containerized apps to Azure using maybe Bicep and GitHub Actions. And this is what we are going to try with the Learn MCP server. So as you see in the slide, a developer here is trying to prompt how do I securely deploy a containerized app to Azure using Bicep. And Bicep is the resource template language that you can use to provision your infrastructure on Azure, for example. So deploy a containerized app to Azure using Bicep and GitHub Action. The GitHub will validate the deployment pattern and provide infrastructure as a code examples. And this is and this question is about infrastructure as a code and DevOps practices. And here, what will happen to you? The agent will first breaks down the query and determines that it involves Azure containers and Bicep and also GitHub Actions, CI/CD. After retrieving the guidance, the AI agent moves on to the implementation. So it will also start the implementation. In this step, the GitHub Copilot starts creating the necessary files and configurations for the deployment using what? Using the results from Microsoft documentation. So it generates things like infrastructure as a code, Bicep templates, and the workflow files for GitHub Actions. So in this step, you see the agent auto-generating code files that align with the searched guidance, so saving the developer from writing them manually and from scratch. Once the agent has assembled the solution, it provides a quick summary of what it did. GitHub Copilot explained the deployment setup it created. So you can ask the GitHub Copilot to summarize what it does. So the GitHub Copilot explains the deployment setup it created and the process it followed. The AI not only builds the solution, but also narrates back the key points, which helps the developer understands the outcome and the reasoning. And this summary, as in the slide that you see now, helps the developer understand the outcome and reasoning, and it helps confirm that how the pattern was implemented. So not just using what it offers, but also understand what happened to implement that. Yeah, in this step, as we mentioned, you can ask how the agent used the Learn MCP. So here is a useful tip for transparency. Ask the agent, describe how it used its tools. In our scenario, after the solution is built, we can ask, how did you use the Learn MCP server to do that? Yeah, so let's start this live demo. I'm going to share my VS Code and here with me, and it is a live demo, so hopefully everything will work. Let's stop sharing and share. This is empty project, just empty project with this prompt. This is the prompt that we just talked about, and I wanted to use this prompt. How do I securely deploy a containerized app to Azure using Bicep and GitHub Actions? Validate the deployment pattern and provide infrastructure as code examples. But before that, I want to make sure that I start the Microsoft Learn MCP server. From the extensions, let's remove that. So this is a way how can I find it so fast. This is the Microsoft Learn MCP, and I already installed it before our demo. And from here, you can see the configurations or the JSON configuration for this MCP server. And from here also, we can start the server. As you can see, once we started the MCP server, it discovered 3 tools. So these are the tools that this MCP server can offer. The 3 tools that we talked about, the Microsoft Learn MCP server can provide. Now it is started. So let's try to run this prompt while we started already the Microsoft Learn MCP. And I'm going to open new chat editor because I did the same demo before our session. From here, you can see the tools that we showed in one of our slides. So these are the available tools for the GitHub Copilot. Okay, let's see what it will offer us. Yeah, I'm going to also allow that. Yeah, there is a Bicep MCP server already. It tries to run this Bicep MCP server, Azure MCP server, and yeah, other MCP servers. Yeah, let's allow. Yeah, this might take a few seconds or maybe a couple of minutes. Yeah, let's allow that. Let's wait a bit for that. Lots of stuff are happening. Okay, let's see what we have here. I hope the screen is visible. So this is the validation bicep infrastructure example, container app environment, and so on and so forth. This pattern. Okay, as long as it didn't apply these changes, so let's ask it to apply these changes. While waiting it to apply these changes, we can maybe continue and get back again to that. Okay. I hope you learned something. And again, we can set up another face-to-face meetings while we can discuss and continue this discussion. I hope you see my screen, and yeah, let's move forward. There are official SDKs for C Sharp, Java, Python, and TypeScript or JavaScript. You can choose whatever SDK you would like to start with. Uh, and what I shared with you are different learning modules on GitHub. So about the official SDK for C Sharp, you can actually build and integrate client functionality into your apps so they can communicate with MCP server directly. And I'm going to share with you the C Sharp SDK for MCP shortly. And there are NuGet packages for those of you who are using C Sharp. Those are the NuGet packages that you should include in your project. And this is how you can start a new console app using .NET, adding these NuGet packages this way. And by adding the NuGet packages, you will see these using statements. And these are few lines of how you can start the builder and add the required services, and then start, build, and run your MCP server in C# language. And those are the echo tools that these like the test echo messages tools that you can add in order to see the hello messages, meaning that you are running or echo tools from your MCP server. And this is the Microsoft Model Context Protocol, or the Model Context Protocol at Microsoft. And the conclusion here is that there is, as you can see, there is a dedication to provide the tools and support needed to build and deploy MCPs, ensuring that developers, students, and users can use the full potential of MCP and leverage the MCP transformative technology. There are many MCP clients and hosts, as you see from this slide. And there are tools, and there is also registry where you can find ready-made MCP servers that you can just use. In order to build a custom MCP, you can use one of the languages that we mentioned. One of them is C#, and you can build either local MCPs or remote MCPs. And all of this are on top of the Anthropic Model Context Protocol. There is also GitHub MCP registry, and the GitHub MCP registry is the centralized community-driven directory, let's say. It hosts various MCPs on GitHub where developers discover, share, and contribute model context protocol. So it's something that you must try. Yeah, these are the links for the tutorials I'm going to share with you. The links, one moment. I shared with you some links, but let's share the other links. I hope you learned something new today, and I really appreciate if you can spend maybe a minute or two filling out this survey. It will help me in the future be better or focus maybe on the stuff that you would like to maybe learn more about. Um, we still have time. If you have questions, we can maybe take it. And remember that this is just our first event and it is online. We thought about starting our first event to be online. And soon we will have other events. One of them is Agent Camp. It will be announced soon in the community, Global AI Riga community. So stay tuned, and it will be a great opportunity to learn something new related to AI and also get some badges and enjoy the face-to-face face-to-face meeting. Apologies, I will share the link for the survey with you one moment. Yeah, this is the link for the survey. If any of you has any question, then yeah, you can drop it in the chat and we still have time. If not, then let's stay tuned and be ready for the next face-to-face conference or event. Um, we are planning for this agent camp, and yeah, let's have some good time together in this event. And there also might be international speakers in this event. So yeah, it will be a great opportunity to meet international speakers, learn something new. Thank you. If there is no question, then thank you and hopefully to see you again and have a nice evening. Thank you. Thank you.